I have to apologize. We've actually scripted this, so we're each going to read our little bits, which I really don't like. But in this case, I think if we all talked about what we do, it would probably go on for 2 or 3 days. So sometimes this kind of discipline is good. Let's see if it is. Anyway, personally, I started designing and building while still in school. At the Yale School of Architecture in the late 60s, there was a culture of what one might call can-do. This was partially due to the ethos of the times, which was challenging the status quo at all levels of society. Perhaps it was a kind of arrogance as well. For several of us, weekends were spent framing houses, learning about plumbing and electrical wiring, and explaining our designs to clients, who were spending very little money on these projects. Eventually, this led to the beginnings of the Yale Building Project, which continues as a first-year studio project to this day. These are 2 houses I built during this period, one with my own hands and the other partially so. There were several others, including prefabricated and modular buildings, following our images of past and present work that we have built since those very early days. For me, from the beginning, the means and methods of building have always been inseparable from the equally important conceptual thinking at the heart of crafting architecture. Design has always been a seamless enterprise, starting with analysis of a client's wants and needs and concluding with a finished working building. Never did it occur to me that one might first design a building and then figure out how to build it, or for that matter, give it to someone else to build. From a philosophical point of view, a further contention is that theoretical and aesthetic claims can best be evaluated when they are embodied in real buildings, which makes demands on architecture that paper and computer schemes do not. It follows that the deeper architect's engagement in the entire process, from the earliest phases of conception to the final details of construction, the greater the chances for the actual realization of a design and the emergence of good architecture. From a more prosaic perspective, we attempt to bring into alignment the needs, those conceptual attributes of a successful building, its context or its fit into its place, its program or use, its structure or its sculptural material presence, and its social imperative or its value to society as a whole. Complete overlap would in fact represent the perfect diagram. Of course, the perfect diagram is unachievable, but the greater the degree of this overlap and the quality of the poetic expression of that overlap in the building's final form is, to a large extent, the measure of its success. What is the process by which we get as close as possible? We accept, in fact, we value the messy evolution that will occur during the development of any initial premise. Our design process is not a straight line. Rather, it is conceptually unpredictable. The process responds to the buildup of information that qualifies and colors design and makes the result rich and relevant. It is a process seeking feedback from the many forces at work on its realization. We start designing knowing that we have great holes in our understanding of how the design of this building will evolve. So rather than fighting to keep our first idea pure, we instead anticipate the struggle that challenges to our first thoughts will provoke. Additionally, involvement in construction allows the feedback loop and consequently the design process itself to stretch over a much longer period of time. We value all the players in our design-build program. We learn from all of our consultants, from individual subcontractors and tradesmen as well. Merging how we think and how we make into one single enterprise is critical to the development of our architecture. It is about making an architecture of substance. We must have total access and transparent relationship with our clients. Architect-led design build provides clients with a single source of responsibility, thus freeing them from becoming judge and jury in conflicts between designers and builders. ALDB facilitates a clear channel of communication, avoiding siloed realms of expertise. Having control of construction allows us to experiment and to push technical limits of design. Our increased level of control provides us with the confidence to assume risks often avoided to the detriment of better buildings. As one of many examples, we have built several underground structures, risking problems with waterproofing that reduce the building's visual impact, are sympathetic to special landscapes, and embrace passive, sustainable design. We have organized this talk into a series of narratives or stories that we think best illustrate what we do. Our four principals, Thomas Gluck, Stacie Wong, Marc, and Charlie Kaplan, each will give a short discussion that provide insights into our architect-led build process. Hopefully, I will win the bet. Thank you. Thomas.
The essence of our process of architect-led design build hinges on the knowledge and information gained by having contact with construction. In the traditional model of practice, there is little, if any, overlap between the thinking and the making. It is well known that design informs construction, but we find that construction is equally relevant during design. In fact, we often find its greatest value occurs during the earliest parts of the design process. For this reason, we have organized our practice to maximize the opportunities for the exchange of ideas between what we feel are the two inseparable acts of thinking and making that every architectural work requires. It is the constant feedback and integration of construction knowledge during design and design sensibility during construction that not only allows us to realize our visions at their highest levels, but informs every aspect of the design process, from its conceptual underpinnings to its material detailing. This first vignette illustrates how a project's most basic concept can be informed by how it should be built. In effect, our experience as makers shapes our process as thinkers. The project is a house on Lake Michigan for a family of 7. The clients were raised in Northern California, and although their careers brought them to the Midwest, their hearts are tied to the West Coast. We were contacted to look at a potential site that the client was hoping to buy, but was known to have bad soil. The site had been vacant for over a decade, passed over by many potential buyers. Before committing to the property, the clients needed to know if the site could be built on efficiently. When we visited the site, we were impressed with 2 experiences. The first was the experience from the bluff, 30 feet above the lake, a horizon of blue sky, blue water, and green grass. Equally compelling, but far more surprising, was the expanse of sandy beach at the bottom of the bluff, which was more reminiscent of California than the Midwest. Along the way, however, we very clearly encountered the problem. Poor soil was an understatement. The edge of the bluff looked like a construction landfill. Research revealed that the site was created in the 1930s when the North American location for the Baha'i Temple was being built. You can see the bulkhead in place to support the coming fill and the foundation for the future temple. Today, the temple stands directly across the street from the project and, given its scale, became one of the site's defining characteristics. This diagram illustrates the primary site strategies. Contend with the institutional scale of the temple and sightlines from the busy urban street, and optimize the unique geography with its wide sandy beach and open green space to the north. But before we could start designing, and before the client could even purchase the land, we had to contend with the soil. The logical solution was to locate the building on good fill, close to the busy street, but uncomfortably close to the temple. Moving it closer to the edge of the bluff would require an enormous amount of soil removal, replacement, and compaction, an expensive prospect given the depth of 30 feet. Piles and caissons were not an option due to the inability to drive and drill through the fill. Our solution: replace the bad soil with the new building. Still in pre-design, we vetted the concept not only with our engineers, but also with excavation, sheeting, and concrete subcontractors. Comfortable that the premium of the foundation could be mitigated, the clients bought the property. Starting now with a technical solution of embedding the building into a bluff, we refined it to further accentuate the unique characteristics of the site. By pulling the building apart and following the line of bad fill, we were able to create 4 distinct outdoor yards, thereby stretching the program out over the entire property, allowing for more diverse and more specialized relationships of the building to the environment. The project then becomes about its section, a procession through a series of indoor and outdoor spaces as one descends down through the bluff to the water's edge. At this point, we were in early schematic design, and the conceptual underpinnings of the project had been developed directly from a strategy regarding its construction. But we wanted to further qualify the assumptions about the foundation by jumping ahead to the next big engineering issue. We knew that by burying the building, a very tall retaining wall would be needed, and given the one-sided lateral loads from the soil, the entire structure would be prone to sliding. The initial solution proposed from the structural engineer shocked us. A wall 36 inches thick with number 9 rebar 6 inches on center and a 4.5-foot deep key to keep the building from moving. We pushed our engineers to look for alternate options, including tiebacks, and then took these schematic sketches to various subcontractors for preliminary pricing. All the feedback was bad. Although we had avoided much of the cost related to the excavation, the foundations were still going to be a premium. Then one subcontractor, who specializes in coastal engineering and remediation, suggested the use of a material called cellular concrete. Cellular concrete is a technique of infusing air-filled foam into a very liquid mix of concrete. It is used for infrastructure projects like this one. Note the scale of these pores relative to the workers standing in the foreground. Its great advantage is that it has enough strength to hold itself together, eliminating any lateral pressure, but light and porous enough to be used as fill. Because its typical applications came from a related field, this solution was not available to us or our design consultants. If it had not been for our ability to access the building trades directly, we would never even have heard of it. In this way, we were able to reduce the wall thickness to a uniform 18-inch thick with only number 7 rebar 6 inches on center and eliminate the deep key altogether. As we were still very early in the process, these changes were seamlessly integrated into the engineering and the design of the building. When we tallied the costs by pricing the subcontractors, this package would reduce the foundation by $250,000. That very week, at the client meeting, we presented the savings along with an option to upgrade the sliding glass window system that wraps the entire beach facade to a very slick zero sightline system from Switzerland. Spending money where you can see it is always a plus for the client. Through this interactive process between maker and thinker, the schematic design of the building evolved to both embody all the goals of the clients, the aspirations to capture and maximize the unique qualities of the site, while at the same time mitigating what made it unbuildable to those before them, which can be seen in this sequence of images, showcasing the experience of moving through various outdoor spaces, into the building, descending the stair as it winds through the house, down to the beach, culminating below in the main living space, forming the light-filled spatial spine of the building. In doing so, the design captures the two main impressions from our first site visit, the view from the bluff for active outdoor play and recreation, juxtaposed with the experience of living on the beach, while adding a front entry court capable of competing with the scale of the street and the temple, and adding a terrace off the bedrooms, remote from the public sequence for quieter, more private outdoor activities. The next few slides taken during construction highlight the process of excavation, foundation, and backfill using the cellular concrete. As with all the projects we will show today, we were not only the architects but also the general contractor, negotiating, managing, and overseeing all the work of the trades on site. The senior project manager, job superintendent, and entire construction team were all architects and GLUCK Plus people. Here a view during excavation looking back up the construction ramp towards the temple with some of the unearthed debris in the foreground. The sheeting is in place and excavation of the lowest level complete. The rubble you see in the background will be reused to form the revetment at the edge of the beach. The first of the foundation pours in progress, preparing for the retaining wall. And here you can see the thin uniform wall being formed and the back slope ready to be filled with cellular concrete. The foundation wall complete and form stripped. But what we didn't realize until the sub showed up is that the high-tech material was delivered with a machine designed by Rube Goldberg, spewing material from a Dr. Seuss book. Actually, what you see here is the foam gun being tested before it is infused into the concrete mix. The slurry of cellular concrete being poured. This had to be done in 4-foot lifts as the retaining wall strength, which ultimately would stand 30 feet, could only withstand 4 feet of lateral pressure of the wet mix. Thank goodness for fishing waders. The last pour held down 3 feet for traditional fill and topsoil, so planting and other landscape elements could be placed on top. And finally, a few more completed images of the house from the beach and from inside the main living space. Views of the main play terrace. And finally, the abstract quiet face from the street.
So our process allows the confidence to push what can be achieved and trust that the building design will be optimized by the creative push and pull of thinking and making, the blending of theory and reality. So in this next story about a new marine science research laboratory for Duke University, our architect-led design build process shaped the ultimate design of the building. And unlike the previous story that Tom described, in which that occurred very early in the design, here it occurred in the middle of design development in response to new information received. This project explored a very timely issue, what it means to build along the coast, including the environmental and technical aspects and consequences of that decision. The setting was a remote field campus along the coast of North Carolina, a 3.5-hour drive from Duke's main campus, a small inner island within a larger barrier island system. And Duke had multiple objectives for this project. First, to design a state-of-the-art molecular laboratory to enable cutting-edge research and new ideas, while taking advantage of the natural beauty of the location, as well as providing outdoor spaces protected from the elements. Second, Duke wanted to energize the campus and keep it competitive by providing architecture that was current, functional, program dense, without feeling institutional or out of scale with the feel of the island campus, which had a small scale, a kind of a rustic sensibility since it was developed in the 1930s and the 1940s. And third, the building had to champion an issue critical to marine scientists, and in this case it was sea level rise. According to Orrin Pilkey, after whom the building is named, and one of the most respected marine geologists in the field, to address sea level rise is to avoid building on the coast at all, or basically retreat from the beach, which obviously is not possible for an island campus. So conceptually and programmatically, the goal was to address sea level rise by not only technically resisting hurricane force winds and future floodwaters, but visually conveying the issue. And so this led to placing mission-critical programs, such as the research laboratories and expensive instrumentation, up on the second floor, well above 100-year floodwaters and projected increases in storm surge intensity, and designing the ground floor to allow inundation without damage to equipment or to fixed building elements. It also led to a relatively solid expression for the building in order to maximize wall space for equipment and storage while minimizing exposure to hurricane. The fourth requirement from Duke was for the building to be LEED Gold with all the complex building systems that are associated with that, but it all had to be done on a very tight budget. And this was a very challenging task. To build a serious lab building, one of the most expensive building types to execute, in an area with hurricanes, high winds, corrosive salt air, damaging sun, and humidity, while using as many local subcontractors as possible in a small rural town where the pool of subcontractors is extremely limited. And the local subcontractors there were accustomed to building small town retail stores, single-family homes, military housing, but definitely not science facilities. Fifth, Duke said that in spite of the desire for enclosure and protection from the extreme environment, the building could not be a barrier to the edge of the island. It had to be visually and spatially porous, and we had to open up spaces and connect them visually to the water. The building also had to recognize the changes in the way that research is being done, not only in the lab, but in debate and discussion outside of the lab. So one of our key design considerations included adding indoor and outdoor spaces that would serve as a sort of collisional commons where students, faculty, and staff can interact informally. So the building provided outdoor spaces for all 4 seasons, all times of day, and protection from sun and heat while being sensitive to seasonally shifting prevailing winds. And on this first floor, all the community is surrounded around the collisional commons. The form of the building derives from the idea that the entire Marine Lab community is around this heart in the building and supports the research happening up on the second floor, which is packed to the gills with labs and equipment, in order to maximize research space and provide for future growth. And then a simple stair constructed of 1-inch thick steel plate connects this ground floor collisional commons with a diversity of gathering spaces up above for a group as well as individual study, both indoors as well as outdoors. And all of this while capturing these amazing views of the water and the surrounding barrier islands. And then finally, Duke's most adamant directive was for the lab and equipment rooms to maximize floor and wall space dedicated to research, experiments, storage, and equipment. And so the scientists were in such desperate need for storage that they said to basically just get rid of the windows up in the lab, which obviously would have been a very short-sighted decision. So we met their challenge while preserving views in daylight by strategically placing windows at desk height and at clear stories, which from the outside resulted in a very simple expression. But to achieve this end result that met all of Duke's criteria was not a linear path. The initial dilemma, which we recognized in the first month of programming, was that Duke's budget didn't match what they needed programmatically. The last research lab built on campus was in the 1970s, and they desperately needed a state-of-the-art facility to attract 3 new faculty members and their accompanying research staff. The program, however, was 37% larger than what they could really afford, which would have translated basically to the loss of 1 faculty member, which was an unacceptable proposition. So our ALDB process allowed us to push it, initially designing a larger building than what the preliminary budget deemed appropriate, because of our confidence in the process. So what does this mean and how do we do that? We designed a building that looks very different than what we ended up with today. And what you see on the screen is a simplified massing of a very detailed design that we did that achieved all of the criteria desired by Duke. And then we took that design and we drew up preliminary pricing and scope sets and started testing the local construction market to basically see what subs were available, to understand their skills, and through direct interaction with local subs, determine what the building cost, trade by trade, in order to target how to make the building better and to get it within budget. So through this exercise, the pricing revealed that the building was $5.5 million, or $800,000 over the budget. So from a positive perspective, I guess the building was only 17% over budget, and we achieved a building that was 37% larger than expected, but we still had $800,000 to get out of the project. So we basically entered into a 1-month period of redesign and figuring out how to get money out of the building. So the making, or the interaction with the subs, definitely shaped our thinking. So to reduce costs without losing program, the most cost-effective way was to basically take the form that we had, maximize the overlap between the first and second floors, which resulted obviously in an uninspired design, as this basic rectangle couldn't possibly meet all of the aspirations that Duke had. So we took this opportunity to make the design better and not just about being less expensive. And we started to shape the building, creating a wider diversity of spaces. And then through this process, we honed in on the fact that the reason for the building was about the spaces in between and not about the building form. By redesign, we found the true essence of the building. And the building visually and conceptually became not just about sea level rise, but it also became about the collisional and collaborative nature of research. And we were able to redesign with more information, with real cost information from actual subcontractors in order to make the building better. But we still had to make sure that this design would also bring down costs, and we knew that we were targeting that $800,000. So, especially since we would be constructing the building with the guaranteed maximum price, we really had to make sure that we were going to be able to achieve this. So we took these 3 buildings, the original, the baseline rectangle, and this new collisional form. And through direct contact with the subs, took every trade, determined what in that trade was driving up costs, and used that input to inform the design changes that were being made. So we reduced the size of the building footprint to affect excavation as well as foundations. We created greater overlap between first and second floors to reduce MEP, horizontal runs, the amount of masonry, carpentry, and roofing. We reduced the surface area of exterior cladding and soffits, found lower cost glazing systems, placed outdoor decks on grade to reduce stairs, railings, decking, and complicated roof details. We worked with local subs to find alternate systems for interior finishes that didn't alter the quality, but were more cost-effective based on local practices in the area. And the resulting compressed footprint also simplified landscaping and paving. And with these lower construction costs overall, the associated fees, insurance, and contingency costs reduced accordingly. So this effort resulted in a building that met the client's aspiration for the price they could afford. The baseline scheme did prove to be least expensive, not surprisingly, and that was approximately $120,000 less expensive. But this transparent and comparative design and a cost exercise allowed Duke to make an informed decision on what the building should be and how much they wanted to spend on it. Like most buildings, cost is one of the biggest drivers, and through our ALDB process, we found that the essence of the building was revealed through that struggle with the budget, and that the design got better for it. By being both makers and thinkers, and not only were we advocates for Duke's budget, but we were also fighters for the design.
So we thought we'd change scale a little bit and highlight two projects in which the ALDB process allows for extremely nimble and effective detailing. Our involvement in the fabrication process not only reinforces the design intent, but often allows detailing that would be prohibitively expensive with traditional delivery methods. The first project is located in North Carolina and is situated on a bluff overlooking the Blue Ridge Mountains. Diagrammatically, it's a linear house justified along a tree line, and by siting the project along the edge of the property, we were able to maintain a meadow space in the foreground, tuck the sleeping spaces along the tree line, and push the living spaces out over the edge of the bluff. The plan is made up of a series of smaller cabin-like elements leading to the main living space, which frames a view prominent over the mountains. It was determined early on in the design process that there needed to be a unifying architectural element to enforce the experience of transitioning to the view. At the very end, the house engages the bluff with a two-story space opening to the view. Historically, the Blue Ridge Mountains have been known for high-quality handmade furniture production, and in turn, we came to find out that the wood and carpentry tradesmen in the area were very skilled, and we were presented with the opportunity not only to collaborate side by side with amazing craftsmen, but embed a historical and contextual reference to the project. The entire region was also known for its lumber mills, and the inspiration for the sticked lumber wall came from the imagery associated with the lumber trade. This is actually a pile of sticked lumber that was on the original site when the owner purchased the property. So once this design idea was identified, it was now on us to determine how to translate that idea to the physical fabric of the building. For it to be successful, the wall needed to read like a true stack of drying lumber, meaning that it had to embody the random characteristics of the wood, the color and the grain, the various widths, the spacing, and most of all, the ends of the pieces needed to read as a massive grouping running all the way through the building. And given its size, the size of the wall, and the sheer amount of wood it would take to build, we realized that we had to be very focused on how to execute the construction of the wall. To achieve this goal, we needed to find a group of local craftsmen to collaborate with early in the schematic stages, to vest their skills and knowledge with our management abilities. This exchange is always collaborative. Often we find very skilled labor capable of executing the work at a very high level of craft, but they simply need a hand understanding what they're being asked to do. We try to build solid working relationships with all of our subs and tailor our drawings to each one of them in order to convey the information in a language that's most understandable to the people actually doing the work. The shop drawings were done in-house, piece by piece, each one labeled and numbered by us, and we were working side by side with the craftsmen in the shop and in the field making required adjustments so the learning was reciprocal. The solution was extremely cost-effective, but most of all, its execution elevated the design of the project as a whole. In the end, the wall was a very simple idea, but it required an extremely careful and managed execution in order to achieve a unified architectural expression. So for anyone in the audience that has a preconception of what a general contractor looks like, the woman in the window is our construction superintendent. Educated as an architect, she worked on the design of the project in our office from the very beginning. She volunteered to move to North Carolina and ran the job site from sunrise to sunset. She, as well as other architects from our office making up the project team, acted as managers, accountants, safety directors, means and method coordinators, and more often than you think, subcontractor psychologists. And when the project is complete, they can return to our office with the knowledge of building a building and the knowledge that changes the way that they design for the better. So the second example is an affordable housing project in which we acted as the developer, the architect, and the builder. The project is located in Aspen, Colorado, so the idea of an affordable housing project may be strange, but the reality is that few of the town's base labor force actually live inside the town. Most of them live miles and miles away down the valley. We had done 2 free market properties previously, but we were committed to develop this site and to address this social condition directly. The plot is situated at the base of a steep hill on a lot that was once a working silver mine and directly adjacent to Aspen's main ski lifts. The prime site had remained empty for years due to environmental mine tailings contaminating the site. The project uses a palette of industrial materials, one of them being corrugated metal, to relate to Colorado's strong mining heritage. Historically, cladding materials such as these were used for their economy and practicality, and over time their decay led to an industrial aesthetic that is simple and beautiful in its own right. Modern building practices require more sophisticated exterior envelopes, resulting in corrugated metal wall detailing that is heavy and unrefined. This has led to the association of those materials with cheap construction. The more elegant alternatives employ welded corners, which are clean and precise, but extremely expensive, in turn undermining the intrinsic economy of the material itself. The project is broken down from one central mass, with circulation and view corridors, corridors to the hiking paths beyond. This creates a series of smaller units, which, from a design perspective, create more desirable corner units and reduce the scale of the project visually. The result, though, is a lot of corrugated corners with various angles and no 2 of them the same. The welded corners were priced against the standard details and the results were staggering. The welded corners actually added about 60% to the cost against the entire rest of the corrugated metal package. So this is a typical situation where the detailing threatens the realization of the design. It required us to modify our initial idea and develop a flashing detail that accentuated the mitered corners. Now, there wasn't a tool readily available to cut the corrugated metals at the various angles, so we simply designed a new tool, and a very, very low-tech one for that matter. We purchased a heavy timber framing saw, mounted it on a sliding carriage, and made it an adjustable rotating platform. Our control over the process allows us the flexibility to build a tool to express the design detail and do so in a very cost-effective way. This is a comparison between the savings between the welded corner and our saw. So the resulting detail is water and airtight in the same way that the standard details are, but it's more flexible and can accommodate the various angles of design. And at the same time, it's more elegant and refined in a way that highlights the various geometries and forms and the individuality of the apartments within.
Having control of both design and build allows us to work not just on high-end projects with intense detailing, as Marc just illustrated with the North Carolina wood wall, but also to bring design to projects that can't normally afford design. In this next project, our ability to deliver a building under huge budget constraints tested the thinking aspect of our practice as much as any high-cost project. Specifically, how do you deliver a well-designed, quality middle school in an urban environment with a tiny budget and 9 months to build. In the context of the Lady Liberty Charter School, failure to deliver a school on time and within an absolutely fixed and bonded GMP budget would mean closure of one of Newark's first charter schools. In previous projects, we used the fact that we controlled the process from start to finish to inform our thinking and our making. In the context of the Lady Liberty Charter School, we quickly realized that we needed to radically rethink our own making process from start to finish. The not-for-profit developer Build with Purpose helped the school to find a site in South Newark, an underused Ukrainian church school built in the 1950s that could house half the program and included a separate gym converted from an A&P supermarket. The existing school sat unbuffered between a busy commercial street and a residential suburban neighborhood. The new program would need to approximately double the old and provide separate schools for lower and middle. Using the existing school as the lower school, we configured a new three-sided form around the old to house an upper school and create a central courtyard around which the whole community could organize. The central courtyard creates many opportunities while solving many school-specific issues. An open-air connector connects the courtyard to the gym, creating a car court. Single-loaded building circulation in the classroom lines the courtyard, unifying the perception of a school center. The cafeteria accesses the space directly for recess and structured play. The dean and principal's office look directly into the courtyard as a kind of command central for school stewardship. The building itself becomes a protective fence for kids at play and simultaneously shields the residential neighbors from playground noise. The courtyard becomes the main hub between lower and middle schools, gym, parking, and bus. Overall, it is this structured between space that gives the place its unique identity. As we typically do, and has been discussed tonight on previous projects, we did early pricing packages or trade sets to find out what we already here knew, that on-site construction was very expensive and the schedule not very achievable. The school budget was half the typical New York school construction cost and significantly lower than schools we've completed recently, with the all-in hard cost budget of $225 a square foot. Quickly, we began to investigate ways to build off-site, including what is sometimes referred to as modular building, but is really off-site construction, a custom building built in pieces in a factory. We looked at our own past projects. In the early 70s, we designed a condominium using prefabricated wood walls and building components. Last year, we completed the Stack, a non-combustible steel and concrete multifamily building on 204th and Broadway in Inwood. But neither of these are schools. There have been some modular schools built in the industry, but typically the technology has been used for homes, short span light commercial spaces, and dorms. Continuing our research, we then made a road trip to Pennsylvania. The Northeast's answer to off-site wood construction, otherwise known as custom homes. We solicited bids from manufacturers of our courtyard scheme in both the wood modular and the steel and concrete, or as it is called in the industry, non-combustible modular sectors. The non-combustible bid proposals worked well functionally. We could achieve 9-foot clear ceilings, column-free classrooms, but at a relatively high cost, $290 per square foot all in. Cheaper than on-site construction, but still significantly over budget. Meanwhile, only a few of the off-site wood home manufacturers were comfortable taking on a school, though none of those that we spoke to had really ever built one. But we were hopeful that the typically $90 a square foot custom home numbers would translate into real savings for the school. The wood bids did indicate savings, except that, due to the more flexible frames, much work, including siding, large window walls, and the HVAC system would have to be done on site, raising the overall cost well above the budget. Also bad, ceiling heights were compromised to 8 foot 6 inches due to the wood spans, less than ideal for a school. In our bidding and research, we found one manufacturer who was experienced in both wood and steel concrete off-site methodologies and began discussing a new hybrid system, a steel frame with wood stud infill walls, floors, and ceilings. The steel would solve the span and stiffness issues. The wood infill would reduce cost and weight. The spanning capability of the steel frame allowed for 9-foot, 6-inch ceilings and compressed the modules needed to 23. With each module stiff enough to be built 65 feet long, enough to accommodate 3 classrooms of width, and 3 modules together making 3 full classrooms and an associated corridor. The stiffness of the steel moment frame would allow for transport of maximum size modules and would allow for installation of siding and HVAC in the factory, reducing the on-site costs. The wood infill reducing the weight of the boxes, thus reducing the crane size and installation price. We were now close to our GMP. The hybrid system had solved the biggest piece of the puzzle. But to reduce costs further, we looked at other ways to prefabricate. We knew from our trade pricing that a lot of money was in the foundation. During our Pennsylvania road trips, there were more than one, and through conversations with manufacturers, we discovered that many modular homes are set on precast concrete walls. We also had recently used a precast concrete system for its architectural qualities for a retreat in upstate New York. We wondered if the light weight of our hybrid steel and wood system might allow us to use this precast system, knowing that the non-combustible systems would have been too heavy. Pricing packages were sent out to precasters. The walls are 9,000 psi and come with steel studs and insulation cast into the concrete, potentially further reducing site trade costs. The precast system finally pushed us down to our GMP budget and importantly helped us avoid pouring concrete in a very difficult winter. Nobody remembers now, but last year's winter was even worse than this. The beauty of offsite construction is that while concrete was going in on site, steel frames and modules were being built in the factory. There, steel frames went up one by one, an individual moment frame for each module. Walls and floors are made in jigs. The moment frame is clad in wood and fitted with the wood infill. 3 modules, 3 classrooms, and a hallway are welded together in the factory and built up as one section of building, then cut apart prior to shipping and shrink wrapped. Cutouts are left in the roofing system as pick points for the crane. At a certain point, practically the entire factory floor is taken up with a school, but still in pieces. After the plywood cladding facades are ready to go on. In early design studies, we had looked at using patterns of color and texture that would be contextual to the street and as a way of identifying classrooms from inside and out. Once the hybrid system was chosen, we rethought the facade to optimize its expression within the factory and transport constraints. In offsite construction, the mate line needs to be what the industry calls zipped up on site. Using inexpensive cement board and full 10-foot pieces as the baseline material, we created a central band spanning over the mate line. This minimized band could be installed on site, allowing the rest of the facade to be factory installed with minimized cuts. Alternating color bands frame each room, creating a syncopated rhythm on the outside and a singular and corresponding color for each classroom. In the factory, a wall being hoisted into place, clad now with the mate line band ready for on-site cement board in black at the bottom of the screen. Finished, and here on-site, the completed facade in the classroom and hallway. In our construction contract, we guaranteed an August delivery. Otherwise, liquidated damages would accrue to the makers, and in our case, the thinkers also. And more importantly, school closure. With a November start, we had 9 months in which to put all of these hybrid systems together in a finished building with a certificate of occupancy. In November, December, it was excavation, including placement of gravel footings for precast walls. In January, precast concrete install. This took about 3 days, but with weather and the phasing of the crawl space and basement, a full month. Here, the precast walls coming to the site, craned erection of precast retaining walls. The precast walls come complete with studs and insulation cast in, ready for wiring and drywall. It is now February. Site cast concrete should have taken 3 weeks. The weather delayed us a month to March. We now have 4.5 months to get a CO, and all we have is a foundation. With the slab in place, we have something to brace the tops of walls to, but they won't be fully locked in until the modules are set. April. The modules are actually installed in 10 days, 5 days of install with 5 days of bad weather. Here are the off-site modules arriving down the city street of Newark, stripped of shrink wrap and lifted into place atop a crew scrambling to weld each box in place. And new modules set on top of the precast foundation, aggregated and welded together. Zip up, or mate-line modular work. It's the last thing that happens, and it's the most time-consuming of all, turning a series of finished parts into a whole school. It takes us to mid-July to complete the zip-up. Here you see the module 1/3 of a classroom with the whiteboards in place, ducts ready to be attached. The slots of light are mate lines within a classroom. Once all is trued up and insulated, mate lines can be sealed and painted. And now close. Only final runs of finished duct are left. The last 2 weeks involve finishing touches and the certificate of occupancy, installing the factory-built canopy marking the entrance, and the connector to the gym, the final piece of the puzzle. Lady Liberty has a permanent home with a central unifying court. We are not sure if they know if they live in a hybrid, that they live in a hybrid of sorts. In a traditional design practice, involvement with the project tapers as construction nears its end. The architect does inspection walkthroughs and generates punch lists. Contractors give a 1-year warranty and might follow through on it. Our involvement as architect-builder typically extends well past move-in and involves more than the punch list. The next project is also organized around a courtyard, this one rural and residential. Its focus on sustainability and the life cycle of a building from conception until long past completion. 11 years ago, we designed a house in a steep north-south valley in Colorado. The full-time live-in owners wanted every room to face up the valley to dramatic views all around, and particularly to the south. At year 8, they asked us to conceive a sustainable 2-bedroom house with an outdoor pool and hot tub that would not significantly add to their current energy usage and would preserve the views of the valley set up in the original house. We considered sustainability first, not as a question of lead points, but as a question of design. How could we configure the building in a way that was responsive to this incredible landscape? How could we situate the building not only to protect the owner's views and privacy, but maintain and celebrate the perception of the land as a whole, from their house, but just as importantly from the road and the mountains beyond? Starting with a small court and meadow inscribed in the first project, we conceived of the new house as an extension and bookend to the original, forming a protected mountain courtyard with a sea of native wildflowers. Then buried the plane of the roof in the earth. The south side of the courtyard is then canted to face true south to maximize solar gain, creating a solar carport. We studied the earth not only as an insulating medium, but as the stuff of the building itself. The earthen roof lifts off the grade and separates to create living space and sunken court, all but hidden from the road. The native plants of the mountain meadow allowed free reign over the building, the earth insulating the house. This is the view from the existing house. The new building preserves and accentuates the original view. And looking back from the new to the existing house along the new courtyard wall, the sunken courtyard with fire pit and corten. On the south side of the house, in the solar carport, the house is unearthed and exposed to the sun. The walls lined with 500 square feet of solar hot water panels to heat the house, pool, and spa. Rather than attach photovoltaics or hot water solar panels to a roof or set them on the ground as is typically done, the solar panels are conceived instead as a thick wall, not earthen here, but programmatic. Panels are canted 30 degrees to maximize winter solar heat gain when the ability to reduce house energy usage is greatest. The steel frame creates a cavity for solar piping and servicing. The exterior wall is inboard of the solar panels and built out even thicker with millwork. The clear story above bounces light off of this deep light shelf, using the sun to light the corridor without glare and with minimal heat gain. Operable windows in the clear story correspond to operable solid panels in adjacent bedrooms, providing cross ventilation through to the main courtyard. Overall, the solar panels work to inject heat directly into the main heating loop, serving the three main energy uses of the house: domestic heat, pool, and spa. A smart controls hub divvies out heat, prioritizing solar usage over boiler. It is programmed in general to minimize natural gas usage. The piping required to make these controls work and have flexibility is inherently complicated, even more so when considering the continuous clear story that wraps the building to track the sun and views. How can a hot water solar system be controlled, especially when all of the piping needs to be run underground and land in scant few walls? Coordination is key to this install. Layout such as this needs a thinker's hand. But what really happens to a high-tech, sustainable building when the building is finished? Can you simply plug and play, as we are so apt to want to do? Or is there an opportunity to tune the systems to how a space is occupied and used? Here, 6 months after occupancy, with the solar systems operational and performing to spec, we noticed in our monitoring of BTU usage what seemed like spikes in boiler usage on summer evenings. Clearly, the boilers were kicking in to heat the pool in the relatively cold Colorado summer nights. We pooled our consultants, control sub, manufacturer, plumbing subcontractor, and solar manufacturer and owner, and found that by raising the daytime set temperature a few degrees above set point, we could store latent solar heat in the pool to bridge the cooler nighttime temps. On sunny days, boiler usage was reduced to 0. After seeing how well this worked, we applied the same strategy in winter for domestic heat. We programmed the system to override daytime set temps when the house was unoccupied, increasing the set temp from 70 to 75. This allowed the massive concrete floor pavers to store latent radiant floor heat during the day and release it in the evening when occupied again, thereby lessening and often eliminating demand on the boiler. These post-occupancy modifications were critical in making the system optimally sustainable and required thinker makers as central to the process long after the C of O and move-in. Without the thinker and maker involved as the quarterback at the intersection of questions of occupancy, use, and technology, the system cannot perform at its best. Even in projects that don't use high-tech monitoring and systems, today's buildings have an inherent complexity of systems that require more than the simple turnover of information in the form of product binders. We designed a series of digital and paper manuals organized around how the building is maintained, distilling information so that it can be used by the owner. Buildings are no longer only about space, but information too. Information in the myriad and overlapping building systems that require a designer still thinking about use in space to distill and dissect into color-coded maps, diagrams of AV systems, heating zones, and more. The goal is simple: that the user seamlessly understand and inhabit their space, ideally melding everyday living with responsible stewardship. There are many more stories that we could tell. As making thinkers and thinking makers, we, as the architects, become active participants in shaping the story of each project, authors of the overall narrative of architecture itself. Thank you.
So part of my job here tonight is to focus the Q&A session on what's important to them, and I think a lot, again, as I said, for me was it's all that this is all for the purpose of design, right? Other than a client's budget or a great service, they didn't really talk about their own business model or profitability or other things that architects who take this level of control tend to focus on, right? So I'd like to continue that theme as we talk about the issues this evening and more focus the questions on how you achieve these things with your clients and how you prioritize some of that stuff. So I guess for me, the first question, or for me the most obvious question, I guess, is how did you initially get so comfortable with the idea of taking on so much risk, right? And what is the process for convincing your first client that this is actually right, that you should have the level of control that you desired?
Real quickly, the first time we actually formally did this was we had designed some additions to a Mies van der Rohe house, which required extreme precision in construction. And about halfway through the project, we realized the contractor wasn't able to do it, so we did it. At the end of the project, which was a pretty involved project, I was wondering to myself, why did the contractor get paid for it and we didn't? We did all the work. So the next job that we had, I said to the owner, how about if we built it? And he said, really, you can build it and design it, and I only have one guy to deal with? And I said, that's right. He said, fantastic. And I've found since that there's much less resistance to this kind of thinking than there is fear in architects for asking the question.
You know, whoop, did we just lose my audio?
You want to use this one?
Yep. Okay. All of a sudden the ringing went away. It's funny, right? The design process for you really never stops, and one of the things in the videos is this concept of drawing full scale, right? Which is something that was in one of the images but not so explicit tonight. And I guess, do you find that your own process of drawing full scale and choosing when to design can actually at sometimes limit the formal possibilities of what you're making?
I mean, I would say, and you could see by the work tonight, that no, in fact, we feel very much liberated by it, because where you might design a very complicated geometry and then fear that it might get lost or become maybe difficult to achieve, by being the one who actually is out on site laying things out, we're very comfortable in, making that translation. And if you think about it, even in a traditional practice or a traditional role of where the architect role might end, it's very reasonable to imagine that the final layout on site, which is really just the drawing of the building full scale, in situ, is maybe a more logical place to draw that line than on a piece of paper, you know, on a roll of drawings that then has to be translated. It's the last bit of the drawing process.
Right, so when do you stop, right? How often do your clients, you know, or do they ever get so invested in the process where they're sort of like, are you guys going to stop designing soon? And when are you going to be done? And how do you negotiate those sort of inherent conflicts of wanting to continue to make it better and choosing those moments to design, right? I feel like, certainly for me in our practice, where we have control over everything and that there's nobody to tap us on the shoulder and be like, all right, quit. So how do you negotiate that internally?
The only answer that I can have is that right now a good number of our projects are second projects from our clients, so they sort of came back for more. So, you know, I'd like to say one thing about what we do, because it seems so daunting, and one can think that how do you know all of this stuff? We don't know anything. You know, all of the knowledge that we gain from past projects are just translated into kind of confidence that we can figure out how to do something. And the something is always different. Actually, the knowledge is kind of a bad thing, because you learn where you had problems, what you did and what you can't do or what you didn't do. All of that impedes the ability to think freely and solve problems, which is what we're all taught to do. And it's the difference between knowledge and wisdom. Wisdom is what eventually happens, and then you have the courage to do things that really you probably shouldn't do, like try to design a school in 9 months with a fixed price, because you want very much for these kids to go to school.
Right. So the choice about risk in this instance, and it's so clear to me in the practice, is just all about making the best possible building that you can make, right? And it's so refreshing and enjoyable in a way to see the architect take on that level of responsibility for a social good or the good of their client, or to provide better service and to just achieve the making of a great thing. I mean, how often do you find that that's opaque to people? I mean, at this point in your career and in the generation of the practice, are people coming to you specifically for this, or are you competing on common ground with people and then having to expose them to a new reality of what's possible?
I think part of it is that I think very often clients come to us because they've seen the work. And it's the same experience my father just mentioned, which is then when we suggest to them that we can also build it, it just seems like a bonus. One of the things about risk is that by building and by being in control and by trying to really make not just the design as good as it can be, but also the realization of it, it really is a way of limiting risk. So by building buildings like the buried buildings, which require real precision and attention to waterproofing detailing and the actual completion of every waterproofing detail, by being on site, we actually it makes us safer to explore and to push limits harder because we're quite sure that we can on site watching it make sure and ensure within the greater team, contractor, consultant, and architect, that it is done right.
So what's gone wrong?
Oh, I'm sure we have some.
No, come on.
We make lots of mistakes. Everybody makes mistakes, and there's many opportunities to do so in a construction job. But the transparency of our process is what I think is critical to the whole thing. That everybody in the process is part of our team, and our client is aware of everything that we're doing. So when we do things that are not normal practice, because the purpose of them is to protect the architect from, did this go off? To protect the architect from risk. The reality is that once the owner realizes that it's in the service of his building or his budget or whatever, this whole business just falls away. Just immediate. Usually after 2 months of working with us, it just disappears.
And that's just by owning the transparency, right? Which is just being really explicit in the process. Do you find that your communication as a result is different? And do people accuse you of the CYA letters or the process of telling everybody, I'm telling you this could go wrong, so when it goes wrong, I can tell you I told you so? Or how does it, from a practice perspective?
No, because we going to do it, and it may go wrong, or if it does go wrong, the wrongness will be much less than the rightness.
I mean, I think that the bottom line is that, every single design and construction project, there are problems. I don't think anybody in this room who practices would say that they had a project where everything that they did, the client loved them and thought they were the greatest thing. But I think the big difference is that because it's the single source responsibility, whatever problem happens, it's on us to fix it. So the owner, the clients, they know that if something is not going right, they communicate, they don't think something is going right, and they know that we're going to own it and we're going to fix it. So, I mean, I think that's the biggest thing for a client, to just know that it's going to get taken care of. And then they're not, as Peter said in his intro, they're not having to be the judge and the jury. They're not going to have to mediate between, a contractor who's pointing a finger at the architect and the architect who's pointing a finger at the contractor. I mean, we're pointing a finger at ourselves, and that takes about 1 second, and then we move on. So
Every problem is our problem.
And I think the key to solving problems when they do come up, and they do come up,
Or issues, we like to call them issues.
which is a euphemism for problems, is the same. The solution is the same solution to what we've tried to show tonight in terms of our design approach, which is that it's what Stacie said when she was showing the Duke project. We trust the process to come to a solution. We can't pre-decide or see ahead into the future what the solution may be. We can't see the problems. If we could see the problems, we would avoid them. But by trusting the process of really working together with contractors, consultants on a team where everyone is aligned to solve the problem. And that comes through no small part of the single source of responsibility, where it's in our best interest to make to really come up with a solution. So that's how we can solve problems when they come up, and that's how a lot of the initial design solutions are even generated. We don't have the knowledge on any one project to see clairvoyantly of the end game. it's a process that we believe and trust will reveal itself. And that's very much, I think, how we deal with these issues.
So now that you have a process, right, the process of design, the process of documentation is unique, the forms of communication, there's so much that's unique about the way that you go about interacting with clients or building. Do you feel like you've now solved it, right? You've created the new widget? Or is there, with new building technology, I mean, building technology is obviously changing daily these days with new materials and different ways to visualize things, but how often are you embracing even different ways of attacking problems, or do you find that the kind of silo that you've built is where the foundation is fairly solid at this point and tested and such that this is the way we do it?
I think you're talking about cracking the code. That's a word we've heard recently that doesn't work so well. I don't think we feel that we've cracked any code at all. I think maybe we get a little bit wiser, as I said, about the difference between knowledge and wisdom. But it doesn't stop. I mean, I feel that this is what we're supposed to do as architects. I don't know how it's happened that architects have kind of positioned themselves in a hole that they only do this or that. We just take on the responsibility, and it's not that complicated. There's a lot of stuff. It's none of which is very complicated. There's just a lot of it. I think that's kind of it's kind of the answer. You saw my mother up there nailing a piece of plywood that was on the house, the first house that I built. We kind of use that as the demystification of the process. It's just not so mysterious. It's very possible.
Is it just pure fear that drives people away from taking the responsibility in your mind? Do you wonder, why isn't everybody doing this? Like,
I cannot figure it out.
We've been asked the question many, many times, like, how do you do this? And ultimately, we were talking about this on the way over, that the difference between a contractor and anyone in the audience is knowledge and insurance. So knowledge is free, and anyone can get that knowledge if they choose to seek it out. And the insurance is just something that you buy.
Paid for by the job.
And it's, yeah.
Contractor's insurance is paid for by the job. The architect, for some reason, has figured out how to pay for his own insurance.
When you talk about demystifying it, it's not really demystifying. Architects are generally good at problem solving and management skills. So it seems like the proper fit that then they take on that additional responsibility. I think if you look at any job site, you don't have to be a carpenter for 50 years to understand framing. And architects, we're good at drawing it, but then once you see how it's actually implemented, the same way that we make design decisions, we can make drawing decisions and change the way that we draw. We talked about this many times, is that we make drawings in the language of the tradespeople, and that comes from speaking with them and working with them and learning from them, because ultimately they have a knowledge base that's helpful and allows a lot of flexibility to our own design process. So if you're willing to open your mind to that additional knowledge, then the rest of it sort of comes pretty naturally.
all right. Well, that seems like a good place to open up the questions to the audience. So if there are some folks, we have some microphones up close here. It'd be great if we can, yeah, please. No?
You want to use this?
I love the work, I love the business model, and really respect what you guys do. And what I find so fascinating is both how similar and how divergent your firm is from your moderator's firm. I feel both emerge out of the idea that by becoming so myopic in the design and concentrating in the design, you lose control over the design. So by refusing to interact with the neighboring industries of development or construction, you lose a lot of opportunities to control the design and to have a significant influence. And well, one of the projects you were playing, or not playing, you were engaging in the developer's role. And I know, Jared, in your past, you have worked as a contractor. And so I wonder how that project went, engaging in the development role, and do you ever consider engaging the GC role more, and do you think all three can live under one roof, or is it just too much?
Tommy, why don't you go? Or Charlie? Charlie, that's you.
Yeah, I think actually one of the first projects where we acted as a developer was a project that was shown tonight, the Little Ajax Affordable Housing Project. And not only was it a great experience in and of itself, but I think that project, in a way, it fed back into a lot of the other things that we do. Jared had sort of asked, the question earlier about, how do you know when to stop designing? And how do you have a sort of check and balance on yourself, or does the client eventually do it? But I think in a way, by pushing the boundaries of the different roles that we take on, and in that instance being the developer, we learned very, very clearly, what a budget really means, what a schedule really means. And so you take that kind of sensibility into the rest of your practice, into your other projects. Peter always says, we sort of learn how to put on different hats. And it's very important to be able to do that as an architect, to say, okay, now I'm going to focus on the schedule, or now I'm really going to focus on a construction issue. Still with kind of a thinker-maker mindset, but have the kind of discipline to be able to take on these different roles is very important. I think development really has helped us kind of learn how to do that, and we continue. We're working on development projects now where we're partners as well.
For my own sensibility about the similarities for us is that more important than anything else, they're engaging in that choice about what they want to do on a daily basis and how to spend that time. And that's how I choose to run my firm, which is what do I want to do now, and then I deliberately make the choice to go ahead and do that, and it's clear that all of the choices that they make simply have to do with choices about what they want to do. And that means engaging and taking on risk in order to achieve what they want to achieve, right? And it's a different business model or different practice model from that point alone, which is being completely unafraid to start a construction company or have your mother nail in a board or build affordable housing in a place which is surprising and taking on that risk. And those are all social choices that you guys have made, which is what's so interesting about the development choices you've made to date, right? Just as a question, which is, it seems to be so far about social choices that you're making only, which is different from the reason most people enter development.
We're really serious about the social aspect of what we think architecture and in fact modernism is all about. And I think that sort of floats our boat, as they say. And one of the reasons that we're so driven towards building our projects is that we know that we can achieve the same project at maybe 35% less than it would be done by contractor, which sounds outrageous, but we know it's the case. All of a sudden that allows us to do some of these projects that normally one would never think of hiring an architect to do, which is a kind of a scary question, because why is that the case? When there's a really tough problem to solve with a low budget, that should be the place where architects are needed rather than excluded for basically because of their past history, I assume.
And I think our interest stems from the fact that we genuinely believe in the value of good design, and good design on its broadest base. So not just what the building looks like, but that fundamentally good planning, careful detailing, thoughtful siting makes for a better living, teaching, working experience. And these are the fundamental benefits that actually every building inhabitant should be benefiting from.
Yeah, question. Is this on? Yes, it is. the intensity with which you work on these projects is really amazing and commendable. And I wonder, have you ever had a situation where you can't take on a project because you're so spread among work that you're already doing, that the opportunities, because you have to deal so directly in the design and construction, do you find that sometimes something is presented to you and you say, well, maybe next year we can do that, but right now we're tapped out in terms of our staff and the use of our, our people. And there was one other question I had. I'm sorry that I'll just add this to it, that do your consultants, structural, mechanical, come along with you on this, in this process?
I think one of the things, there are times when we can't do something because we're too busy, but I think we do turn work down, but it's mostly because it's work we don't want to do. And conversely, there are kind of crazy things that we decide we do want to do that really don't make much sense, but for some reason we feel it's important to do that.
But it is a good point. I mean, the way that we work is very staff intensive, I think more so than in a traditional practice. So we're mindful of that, but if it's a good project, it's a good project. We kill ourselves to do it. So.
And I think part of the solution or the ability that we have to do that is because we're 5 principals in an office of 40 people, and then within that office, there are probably another 10 people who have all had this experience of having designed and gone out on site and built. So there's an incredible body of knowledge within the office. This is not, that's kind of evenly distributed, and that allows us to take on work where it all doesn't have to be funneled through. I mean, that's why we need so many chairs and microphones today.
And I guess the second part of the question, maybe we should try to address that. We do work with our consultants, I think, again, very differently than a traditional design practice. We typically are actually doing the drawings. So we're doing the structural drawings and the mechanical drawings, and our consultants are literally, we're like the drafts people for our consultants. So we'll draft up those plans, send them to our consultants for markup and stamping. But we find that by doing that, that the whole process of putting a building together, the structural bones and sort of the lifeblood, which are the mechanical systems, are all thought of integrally with the design of the building itself. And we think that's really critical. If you're not drawing that stuff at the same time that you're designing everything else, it's always kind of an afterthought, always something that just kind of gets fitted in rather than kind of part and parcel.
And the consultants actually, they want to work that way because ultimately they're doing design work. They're not worrying about the coordination part of it. And it gives them a lot more freedom to be what they are, which is designers of each individual consultant trade.
We get their brains.
I think one of the assumptions is that this seems like a great burden, and we take it on because we're building and we need the knowledge and we need to be able to know what the systems are and how they really work. But in fact, we find it incredibly liberating as designers, because if you really are cognizant of the structure and what's working laterally versus statically and mechanical systems, then you have all the tools on your plate as you start to consider different design options, and you can quickly test without having to then find out from a consulting engineer whether this is viable or whether this is not viable. And obviously we work very closely with our engineers, but having that kind of base knowledge, which we get by basically drafting in the office, liberates us to try new things and test and kind of push the boundaries from us strictly from a design standpoint that is maybe potentially counterintuitive.
And we push our engineers too.
To your question, what goes wrong? In the scenario where we're doing the drawings, it's very rare that we actually are surprised by something that's happening in the field, and that's across the board. You don't walk out to the job site in the morning, look up and say, what is that thing? Because we've drawn it and we've coordinated it in-house, and it seems like something that architects would just do. But when you look at the one photo that Charlie put up there with all of the hydronic and underground piping coming up, there isn't anyone other than the architect or the builder on site that could possibly understand what all of that means, because each one of those trades is only doing what they're contracted to do. And the interactions between the trades, they come down to whoever's there on site. So often, the problems that come up on site can be solved almost immediately sometimes. This guy just wants to know where to put his pipe, and you can tell him right there and then. You don't have to go through the process of calling an engineer, asking them, can we put a hole here? We can make those decisions, and ultimately the contractors love it. The consultants love it because they're not burdened with that extra layer of responsibility for where everything is going. They can just design, and we can take care of all of that.
I'm curious, what are the challenges you run into, or the biggest challenge with the ALDD process with your consultants, your engineers? Do they balk at that? It sounds like they're very open to that process, but it's completely foreign to any other firm that they would work with. So I'm curious.
I would say that the better engineers like this a lot. It's like teaching a studio course where they're sitting at the table with the architects in the architect's office, talking about the theory of what they do, not sort of running the drafting department. Most really good engineers have to run a drafting department, but are not in love with that aspect of their work. So we take that burden off their shoulders. They also feel that when they design something, they know that's the way it's going to get built. One of the fears that structural engineer, well, all engineers have, is that they can draw something, but the reality is it may not be built that way, which opens them up to liability and responsibility. So there's a lot of money that goes into over-designing to account for the fact that things may not get built properly. So I think our engineers know that when they design something, that's the way it's going to get built.
The question was whether or not they use BIM or Revit or what other types of software are used.
Let's answer that.
So right now we are not using BIM in the office, and the primary reason being, and we touched a little bit on it in our lecture, but the way that we work and price out things with our subcontractors, everything is separated out by trade. And Revit doesn't really allow for that separation out by all of those different components. We've had a lot of conversations with Autodesk actually about this issue. They're very interested in how Revit could be used in the way that we do it with the design build. And so we've been in conversation with them, but we haven't really come to a method of actually doing it. So I think our next steps is that we are going to be piloting it on one of our programs and be in constant contact with Autodesk to basically say where the shortcomings are, where it's not really working with how we're doing things, and it's possible that it may feed into future versions of the software probably many, many, many years from now.
And it's interesting, the reason Revit, which is basically assembly based, because it's coming from the mindset of the architect, which is I can draw a wall, it's got all these different components, and I could assign all these different pieces to it and then draw the wall. But in fact, that wall is 4 trades or 5 trades. And the logic of the contractor, the logic of building a building is not by assembly. There is no wall manufacturer or wall contractor. You have a framer, you have structural steel, you have all these different trades that fit into it. And so and that's how we've chosen to break our drawings up, so that it's really serving the guys, the people on site, which is broken down by 30 or 40 trades in a building, and not the way architects often conceive of things, which is by assembly.
What is the big job of the contractor is to take the architectural drawings, which are conceived of what he calls the set, and has to tear that set apart into 30 separate sets. That's a daunting job that the contractor does. So one of the reasons that Autodesk is really interested in incorporating the possibility of doing trade sets is so that he can sell his software to contractors, which is bad news for architects.
Do you see a limitation to the ALDB process in terms of scale? Is there too large a building or too small a building where it doesn't make sense?
We haven't come in contact with that just yet, but eventually there will be, we'll have to deal with that. When you look at a project and the size, whether it would take that much intellectual knowledge out of the office for a big period of time, that we would have to make that decision when the time comes.
There are halfway measures, though. We're doing a project where we're working with, it's actually a project that we have a development interest in, and there's a contractor who's doing a portion of the work, but we're labeled as construction managers. So we're doing all of the bidding, all of the stuff that really is critical to the actual, all of the pre-construction work we're doing for this contractor. So there are all kinds of ways of partnering with larger contractors. So
part of what makes the question, Jared, you asked about what else we can do, and we sometimes liken it to software, but the platform allows for, even though we have only done it on a kind of a small scale, the platform allows, because it doesn't rely on only what we know, the platform allows for working with different contractors, different trades, different other enterprises, so that it is scalable, and it would be a joint partnership. And actually at a certain scale, there's a lot of stuff we do on site, like locking and unlocking the job fence every morning and deciding where the doors go, that we take on because we're building the whole building, but may or may not be the greatest value as design builders, but that's part of building. And so actually as the projects scale up, there's the ability to team with the contractor who's maybe extremely experienced with those kinds of logistics of construction, and then really optimize what we bring to the table, which is the knowledge of how it was designed, the intention of the design, the goals of the project, or the detail, all the way through. And then I actually think there's an opportunity to have it become even more successful at a larger scale, although time will tell, because as Marc said, we haven't gotten there.
Okay. Can we take one more question, and then I think say thank you. Does anybody have anything? Yep.
So maybe building on your last point, you've seen the makeup of your office change as you've gotten into more of this work. Like, do you really need everybody to be an architect, like a master's of architecture, or are you bringing in people from different backgrounds into your office to sort of break up that work, logistics, tradesmanship?
I'll say one thing to that we find that architects are an incredible underutilized resource.
Well, that sounds like the appropriate place to stop.